is the study guide for Algebra B, Test 2, Quarter 3. And so you're going to end up being tested on some factoring skills again. However, the factoring is going to be a little bit more challenging. And the first problem you'll end up seeing is a four-term polynomial in which we're going to end up having to factor by grouping. We can't combine any of the terms. There's no common factors. So what we'll end up doing is drawing two sets of parentheses around the first two numbers, and then treat this minus 2x as a plus negative, and then group the last two terms as well. So from there, what you're going to end up doing is looking at each of the terms individually and taking out the common factor. So I see x squared goes into these two numbers, and then over here, we end up taking out the biggest factor we can as well. And so I see negative 2 goes into both of these numbers. Now I'm going to take out a negative because I see that these two terms are both positive. These two terms are both negative, so I want them to both be exactly the same when I take out these factors. And we'll see if that's the case. So when I do this, again, I take out the x squared, and then I think, what do I get left over when I take out x squared from these two terms? Well, the two x's down below cancel out two x's on top, leaving me with just one x. These two x's take out these two x's here, leaving me just with the positive 3. So that's what I should get when I take out the negative 2 from the last two terms, and let's see what I get. So I'm going to pull out the minus 2, and when I do the division, yep, I certainly get just an x left over. The two negatives cancel out, and negative 2 goes into negative 6, positive 3 times. So from that point, all we have to do is now take out the common factor of these two terms. And the common factor is a binomial. X plus 3 is what we're going to end up having to take out. And so I'm going to take that and put that on the outside of a parenthesis. So I'll put the x plus 3 out here. And then from there, I'm going to go ahead and take out the see what's left over. So the x plus 3's, again, they canceled out. So what's left over? It's the x squared and the negative 2. So x squared minus 2. Now, be careful on these. Sometimes this last term here might end up being a difference of squares, and that would factor one more time. So be very careful. Always check to see if you have a binomial left over, does it factor one more time? And you might see that with a four-term polynomial, especially when one is the highest degree term is in x to the third, so that's a third degree polynomial. Sometimes you see that difference of squares, but this time we didn't. Well, we take a look at the next one, and what I end up doing on these is I look for common factors to make the factoring go easier. Notice that the directions say factor completely. So you might end up seeing a common factor in these terms, and that's what we see here. I see 2 goes into each of these numbers. So it'll make the factoring easier at the end, and since they say factor completely, we're taking out the 2, taking out the common factor. So let's see what's left over. 4x squared minus an 8x and a plus 3. So what I'm going to look at from here to be able to factor it is I'm going to look at that last digit's term or sign, and that is a positive, which tells me to add the outside and inside terms, and I should end up with a negative 8x. So when I do that, it tells me both signs need to be negative in order for it to add to make a negative. So first thing I'm going to do is I'll make sure I bring down that 2, and I'll draw the two sets of parentheses, but this time I'm starting with the prime number of 3. And 3 and 1 are the only numbers that make that, and I know both signs are negative. So all I have to do now is figure out what numbers go in place of the first terms to make 4x squared. So I've got some options. I can either put a 4x and a 1x to multiply by to make the 4x squared. I could put a 1x and a 4x, or I could put a 2x and a 2x. Now, remember, they need to add to make 8. So you don't want to multiply 3 by anything that's going to make something bigger than 8. And so I'm going to first try the 2x and the 2x here and see what happens. So again, I have to check the outside terms and the inside terms. So I get negative 6x and a negative 2x, and sure enough, that makes negative 8x. So it does end up working. So we've got it factored. So 2, make sure you bring that down. The 2x minus 3, that's one of the factors. And the last factor is 2x minus 1. So there it is. That's the factored form. So let's take a look at the next one. Now this one, again, says factored completely, so always look to see if you see any common factors. No common factors there, so that means we're going to look at that last digit sign. It's negative. Tells us that the outer and inner terms are subtracting this time to make a negative 5x. Alright, so we're going to go ahead and draw the two sets of parentheses. This one's a tough one because we're not sure what we should put in first because we have no prime numbers. So we've got options. Numbers that make 6 would be like 2 and 3, or we could have 1 and 6. Numbers that make 4, we could have 4 and 1, we could have 2 and 2. So what I'm looking at is the outside and inside terms need to subtract to make 5. So that means I need one that's bigger, one that's smaller. So my first guess is I think it's going to end up being a 2x and a 3x to multiply to make 6x squared. That's just a guess. And then I need to think about how can I get a number that multiplies to make something bigger than 5. And so as I think about it, I don't want it to be too much bigger, but a little bit bigger. And so I'm going to go ahead and try to multiply maybe like the 4 over here and the 1 over here. Now, if that doesn't work, I could end up trying this way as well, 4 first and 1 second, and I could try a 2 and a 2. So I'm checking the outside terms and the inside terms. So 3x and 8x. Yep, those do subtract to make 5x. Now, I'm not done yet, though. I need to make sure I get the right sign. So I need a negative 5, so that means I need more negatives than positives. So it's going to be a negative 8, positive 3. So let's see how we get the positive 3. Means the 1 needs to be positive, and the 3 is positive, so that makes a positive 3. 2 times by a negative 4 makes the negative 8, so that ends up working. 2x plus 1, and we end up having a 3x minus 4. So there's our answer. Well, taking a look at the next one over here, we've got a negative 3x squared plus 13x minus 14. So I'm going to factor completely. I'm going to go ahead and take out the negative, because when I factor, I like to have this first term being a positive. It just makes it easier for me. So I'm going to go ahead and take out a negative 1 from each of these terms. So I take the negative 1, put it on the outside, do the division. Let's see what's left over. 3x squared. It's going to be a minus 13x now, because the sign will switch, and a positive 14. So let's see what that means for us. Well, when we go ahead and close the parenthesis here, when we go ahead and check what we should do with the outside and inside terms, I'm looking at that last digit sign. It's positive, so that tells me I need to add the outer and inner terms. And when I do so, I should get a negative 13x. So I'll go ahead, and first thing I'm going to do is bring down that negative 1, draw the two sets of parentheses, and this time we're fortunate. We have that 3x squared, which means it's prime. So the only numbers that make 3x squared are going to be 3x and x. Now I've got to think of the numbers that make 14. So I can figure out the sign right now as well, because I know it needs to multiply to make a negative 13. So I know both signs are going to end up being negative. So I'll put the minus signs there. And so now I don't want the 14, I don't want the factors of 14 to multiply to make something bigger than 13. So remember, I've got the options of 2 and 7, I've got 7 and 2, 14 and 1, 1 and 14. But I see right away, if I use 2 and 7, 3 and 7 multiply to make 21. That's bigger than 13, so I know that's not going to work. I know, oops, I have the same one here. Let me go ahead and fix one of these. Let's call this one 1 and 14. I know this one that I just wrote down, 1 and 14. 14 times 3 is going to make 42. That's going to be bigger than 13, so I know that's not going to work. And I know 14 is already bigger than 13, so I know that's not going to work. So that kind of limits me down to what the possibilities could end up being. So let's try this one, make sure it works. Otherwise, it's not going to end up factoring for us. So this makes 7x, negative 7x. Makes a negative 6x. Yep, that does make a negative 13x. So it does end up working out. So we can go ahead and write those as our factors. Remember, make sure you bring in that negative 1. You also have the 3x minus 7 and the x minus 2. So that's the factored form for us. Again, make sure you bring down any terms that you took out. Looking at the next one here, we've got a positive sign as the last term, and I see no common factors. So the plus sign tells me that I'm going to add the outside and inside terms, and they're going to add to make a negative 12x. So what that does for me right away is I know I'm going to end up with a minus and a minus sign. So as I look further, one of the strategies to factor, because oftentimes we got to think, okay, that we got two different numbers that multiply to make 4, either 2 and 2 or 4 and 1. And same thing with 9, 9, 1, 3, and 3. But when both of these are both perfect squares, a strategy for factoring is to see if it's a trinomial square. That means both binomials are the same. So if they're both the same, what you need to do is take the square roots, because they're both perfect squares. This is 2x, square root of 9 is 3. And try those numbers, 2x and 3, 2x and 3. We know both signs are both minus, and then see if it does end up working. So let's go ahead and check the outside terms and the inside terms to make sure it makes negative 12x. Now the rule with this is, since both of the inner and outer terms are going to end up being the same, both, in this case, negative 6x, if you find one and double it, it should end up equaling the middle term of the trinomial that we're trying to factor. And it does. See, these add to make negative 12x, so it does end up working. So it is a trinomial square, and we can go ahead and factor it as 2x minus 3 quantity being squared. So again, it's just a strategy of factoring. It looked like a tough problem, but I saw that both first and last terms were perfect squares, so I tried it as a trinomial square. Well, taking a look at the next one, no common factors, but it's a binomial. So the only way it's going to end up factoring is if it's a difference of squares. And as I say, if it's going to factor, it's only going to factor as two binomials if it's a difference of squares. And so the reason is that the outside and inside terms are canceling out to cancel out that bx term, or in this case the bc term because the variable is c. So what we need to make sure is they're both squares and it's a difference. So we have one minus sign, and sure enough, I've got a perfect square here of 5c, got a perfect square here of 4. And when I go ahead and take the square root, that is. And so what we'll end up factoring to is 5c minus 4 and a 5c plus 4. And you see how the outside terms and the inside terms will cancel. See, negative 20c is the inside. Outside make 20c, and those will end up making 0. And that's why you don't see that middle term with a binomial that is a difference of squares. And so that's how it's going to factor, 5c minus 4 and a 5c plus 4. So those are the first 6 problems you'll end up seeing on your test. Part 2 will have the last 3.